Hello. So today I'm going to talk about coefficient of restitution. What is coefficient of restitution and why do we need coefficient of restitution? Every time there is a soccer match, tennis match, basketball match, especially at higher levels, they always test the ball. You might have already noticed that the players, the referees, they test the ball, and even during the match, occasionally they change the ball. What they are concerned about, among other things, is coefficient of restitution. Coefficient of restitution essentially characterizes how elastic the ball is. So if you drop the ball, it comes back to a certain height, which is not the same as the drop height. So the rebound height is different from drop height. And the question is, how far does the ball bounce off the surface? All right. Now let's say we drop the ball from this certain height, and let's show this height with h1. We know that from other lectures that we can apply the principle of conservation of energy and determine the speed or the velocity of the ball when it hits the surface, right? So we can simply say that the initial potential energy plus initial kinetic energy, which is equal to 0, we have dropped the ball, is equal to final kinetic energy plus final potential energy, and relate the velocity at this point to the height. So I can also add the index 1. And then if we apply conservation of energy again from the point this ball leaves the ground or bounces off the surface, we can relate the velocity of the ball to this height using conservation of energy again. So V1 and V2. Now, the only caveat is that we are ignoring air resistance in applying conservation of energy. Now that we have done this, now the question you should ask is, so what happens during the time that the ball is in touch with the surface? So as a result of this impact, this two-body collision, the ball is in fact elastically changes. Assuming we have an elastic ball, a basketball for example. So the ball initially compresses as you would expect and then expand. So during the drop phase it compresses, during the rebounding phase it decompresses. So the ball compresses and then decompresses, and then the question is, what happens to the energy of the ball, right? Because if you think of the ball as a spring, the spring compresses, stores elastic potential energy, and then decompresses and releases energy. During this process, some of the energy is lost. And because we have lost energy, the ball doesn't quite go back to the initial height. Now, to relate the drop velocity to the bouncing off velocity, we can use coefficient of restitution. Right? So coefficient of restitution relates the velocity, these two velocities together. So I'm going to use, let's say that my ball, this ball is vertically hitting the surface and then bouncing off the surface vertically. And the reason I'm doing that, I'm assuming that, although it's hard to show it in this diagram, is that just so we don't have any horizontal component of velocity. Otherwise, we need to discuss the effect of that component. So we drop the ball vertically, let it bounce off the surface, and we measure or compute the velocities. Alright, so now the question is, so I want to define coefficient of restitution. So I define the coefficient of restitution as v2, the magnitude of velocity, over v1. And we know that the magnitude of velocity at this point is got to be smaller than the magnitude of velocity when the drop magnitude velocity, right? Because we know that this velocity is related to this height. So for the height to be smaller, this velocity has got to be smaller. So the bouncing off velocity is smaller than the drop velocity at this point. Therefore, the coefficient of restitution is less than 1. All right. Now, you've got to ask other questions like, what affect this coefficient of restitution? For example, would it be different if I perform this experiment on a different surface? Would it make any difference if the surface was wet or dry? And you should definitely ask this question that, how about the ball itself? We could have an empty ball, we could have solid ball, and if you have an empty ball, does it matter how much air pressure do we have inside the ball? If we pump the ball, increase the pressure, what happens to the coefficient of restitution? What happens to coefficient of restitution if we play with the ball for a certain number of hours? In other words, let's say, let me give you a practical example, in fact. So those who play squash, before starting the match, they start playing with the ball, a squash ball. So what happens during this, let's say, pre-match warm-up? They essentially also warm up the squash ball, and that change in temperature affects the pressure inside the ball. And think about it, why it in fact increases the coefficient of restitution. So they essentially get a larger bouncing off the surface distance. So, okay, thanks for paying attention to this introductory lesson about coefficient of restitution. Hope you enjoyed that. I'm going to leave you with one question. So this coefficient of restitution was the ratio of V2 over V1. Now think about it. What if this coefficient of restitution approaches 1? What does it mean? And how can we approach that limit value of coefficient of restitution? Thanks for paying attention. Goodbye.